A video on substitution with indefinite integrals. This is a follow-up to you probably want to watch 7.1 first if you want to know the basic power rules with indefinite integrals. We're going to jump in and use du dx, kind of similar to the notation that we've used in the past, and I'm going to show how that is used. So you'll notice that this is a little bit different than the indefinite integral with just polynomials, and that is because it's taken to the fourth power. If you wanted to, you could essentially FOIL this out, or it's not FOIL, but multiply 4 times this binomial, but that might take a really long time. So we're going to shorthand that, and we're going to use substitution. So the first rule in substitution is we want to identify what u is. So in this case, u is this binomial that's here in the middle. It's kind of identified by a radical over top of it. Any binomial that's taken to a power other than 2, because essentially with 2 you could FOIL that out and just make it a basic polynomial, but in this case we have it to the fourth power, so that signifies what I'm going to use as the u. Okay, now we're going to take du dx. Okay, so we're going to take the derivative of this function, so 15x squared there. Okay, now that might be a little confusing because we've been working with indefinite integrals and stuff, but we're taking the derivative because if you recall in the chain rule, we're going to multiply by the derivative. So we're going to show how that works here in just a second. Okay, so the derivative of the inside, or derivative of u. So now what I'm going to do is this is what's new, is we're going to take both sides times dx. So I'm going to have du equals 15x squared dx. And this is very important here, okay? Very important. Oh, I think I made a mistake here. Give me a second. Let me go back. Whoop. Hopefully you caught that. That's going to be the 3x to the fifth is 15x to the fourth, and then 15x to the fourth dx. Okay? So now what we notice is, okay, all right, so I've got this thing set up. I'm going to kind of start working this. Now if you recall with the notation here, if I have u to the fourth, if I replace that, I still have the 15x to the fourth dx. Okay, so that's a problem because I'm not taking the derivative, or sorry, the indefinite integral of x. I want to take it of u. But you'll notice the nice thing that we have here is that du equals this right here. Okay, and you notice how these match up? So essentially what I can do is replace this, because it equals du, with essentially du. So you'll notice here u to the fourth du. Okay, again, I'm able to do that because this equals du. So this, the 15x to the fourth dx, equals du. Okay, so now I have my formula set up. The indefinite integral u to the fourth du with respect to u can be done. So now I have u to the fifth over 5 plus c. Okay, so now all I got to do is replace the u back in there, which the u is 3x to the fifth minus 5. Now I'm going to write this as simply 1/5 3x to the fifth minus 5 to the fifth. All right, so all I'm going to do is I just replace the u in there. I just put 1/5 out in front, and then plus c. All right, and if you took the derivative of this, which you would use the chain rule, we'd take 5 times the front and multiply it by the derivative of the inside, and you would get the same exact function up there. So that is our answer. All right, so let's look at maybe a more complex one here. So we have this one here. All right, so first we're going to identify u. u is e to the 3x minus 5 du dx. If you recall, the derivative of any kind of exponential function with e is we take the same thing, e to the 3x, times the derivative of the exponent, which would be 3. So that comes out to be, let me make this a little bit more spread out here, du dx equals 3 e to the 3x. All right, so that's nice. That's pretty convenient here. All right, so let's solve for du. So we get du equals 3e to the 3x dx. All right, so now we notice the same kind of thing we had earlier, which is u, because we called that u, right? U to the negative fifth times 3e to the 3x dx. And again, we're in a dilemma here because we got two variables here. We want to take the integral with respect to u, but it's certainly dx right now. So what we're going to do, same process I did before, this right here equals du. So I can take this whole expression right here and replace it with du. So then I have u to the negative 5 du. Again, that got replaced. This whole expression got replaced because du equals this. All right, so now I just got essentially just working through the problem. So I got u to the negative 4 over negative 4 plus c. And then I'm just going to kind of clean it up a little bit. I got negative 1/4 e to the 3x minus 5 to the negative 4 plus c. And again, if you were to take the derivative of that with using the chain rule, you would get our original problem right here. Okay, I think I'm going to post just one more video where maybe perhaps this doesn't quite match up with this, but kind of the same path. We just have one little step to do beforehand. So hopefully this video helped you out. Please email me if you have any questions.